Yes, a simple and nice string concatenation can totally kill the performance of your Python code. In this video, I'm going to show you how that can happen, why and how to fix it. With a bonus at the end, I'm going to go dive into string concatenation, time complexity, and BigO notation. So watch until the end and let's get started. In general, there is no problem with string concatenation. String concatenation is one of the first and most used features in programming. You learn variable basics, integers, booleans, and strings. It's even one of the first things we learn in Python official documentation. As illustrated in the picture, strings can be concatenated, glued together with the plus operator and repeated with star. So yes, string concatenation is not bad at all, and it might even be impossible to do programming without needing to concatenate strings for one reason or another. Although, like almost any useful tool or feature, when used the wrong way, it can lead to really bad effects. So it's important to be aware of how to use them correctly. So, when string concatenation could be dangerous, you should pay attention to string concatenation when these two conditions are met. The first one, the feature is a performance critical one. For example, a test data analysis feature on a web application that is running and a user in the website interface is waiting to get back the result. So your code should be fast as possible. Second, you are dealing with a lot of concatenation, starting from 10,000 because of a loop maybe, and or the strings you are concatenating are really long. That can lead to significant overhead in terms of memory allocation, garbage collection, and slow down your code. And in the worst case, just make your code crash in production. That's bad, right? And that also means it's totally safe to use string concatenation when those conditions are not met. And you're sure these conditions can never be met in the future. So, for instance, a simple concatenation to build the full name using the first name and the last name is totally okay. Because there is no way someone's name can become long enough to create a performance issue. Anyways, not in these words, right? So, why string concatenation is dangerous in those cases? In Python, strings are immutable objects, which means that every time a string is concatenated with another string, a new string object is created in memory. To illustrate that, let's run this simple code. So, here we have my str string, and we are trying to concatenate hello and word. So we have printed here the ID of our string before the concatenation and the ID of the string after the concatenation with word. If you didn't know, the ID function in Python returns the identity of an object. The identity of an object is an integer, which is guaranteed to be unique and constant for this object during its lifetime. So with the ID function, we can make sure that our object is the same. So if the ID is not the same, that means the object is not the same one. And the output is here. Before the concatenation, we have this ID, and after the concatenation, we have this ID. And as you can see, those two IDs are different. That means Python has created a new string. So my str here is not exactly the same object as it was here initially. So what is the solution to that issue? And a comparison with string concatenation. To address this performance issue, you can use alternative techniques such as using a list to hold the individual string components and then joining them together using the join method. Python doesn't create a new list each time you append an element, and the join method is optimized to avoid creating a new string object for each string in the list it has to join. That's why the join is more efficient. So, to illustrate that, we can run a simple Python code. In the first case, we have concatenated a string 10,000 times with the character A, and we have printed the time it takes for the string concatenation. And in the second approach, we are using join. We did the same thing. We appended 10,000 times the character A to an empty list, and then we are trying to concatenate it using join in one line. And we have printed also the time taken for the join. And finally, we have printed the performance gained when we use join over the string concatenation. And if we run the code, you can see that here we have the time taken for the string concatenation. That is really more than the time taken by join. And when we check at the performance, we can see that we gain almost 32% of time performance. That's really a lot. Now, let's dive deep into the why. Math and BigO explanation. This behavior could also be explained using BigO notation, especially in the time complexity. Let's focus on the concatenation part of our previous code. So we have a string S empty at the beginning, we have a string C here, and 10,000 times we have concatenated S with C. So here N equals 1 and M equals 10,000 times. So keep this in mind. The complexity to create a string of length n is O(n), naturally because Python has to go through all the characters of the string. So because concatenation creates a new string of length s plus c, the complexity of the concatenation at each iteration is the length of s at the previous iteration plus the length of the string c. Yeah, at each iteration, s is growing progressively. So the complexity for each iteration is the length of s at the beginning of the iteration plus the length of c, which is constant, which is 1. In this table, we are trying to simulate the iteration. So at the first iteration, the string s is empty, and the concatenation operation is s plus c. So empty string plus c, which gives c. And the time complexity at this iteration is the length of s plus the length of c. The length of s is 0, and the length of c is 1, which gives 1. And the overall time complexity is 1. At the second iteration, at the beginning, s is c because of the previous iteration. And the concatenation is then c plus c, which gives cc, and the time complexity is 1, the length of c, the length of s plus the length of c, 1 plus 1, 2. And the overall time complexity is the sum, 1 plus 2 here. At the third iteration, s was twice c, and the concatenation is then s plus c, which gives 3 times c, and the time complexity is the length 2 plus 1, 2 plus 1, which gives 3, and the overall is 1 plus 2 plus 3, which gives this one. At the fourth iteration, s initially was c, then s plus c gives this, and the time complexity is then the length 3 plus 1, which gives 4, and the overall time complexity is the sum here. At the fifth iteration, s was this plus this, that gives this, and the time complexity is the length 4 plus 1, which gives 5, and the overall is again the sum here. And if we continue like that, at the iteration m, the concatenation, the time complexity will be m, and the overall time complexity will be the sum of all iterations. So 1 plus 2 plus 3 plus 4 plus 5 until m. Now, as you can see, the total or overall time complexity is this sum, which we can mathematically approximate at m times m plus 1, the all divided by 2. And by neglecting the minority exponent, it will remain m squared. So the complexity here can be approximated to OM squared. That is bad. So let's try to see the time complexity with the join approach. In the join approach, we have an empty list, and 10,000 times we are appending the character C to the list and finally join in one line. And to compute the complexity here, we can divide it in 2 steps. The for loop. Here, to do the for loop, Python has to go 10,000 times and append C. So we can approximate the complexity here to M. M equals 10,000. So the complexity here is OM. Now the second part is the join part. Here the complexity is T, where T is the total length of the final string after the join, which equals again N times M. Why? Because to join a list of M strings of length N, Python has to go through all the strings in the array, and for each string, it has to go through all its characters. So the final time complexity here is the complexity of the join, N times M, plus the complexity of the for loop, M. And we can approximate this to Mn or Nm if you want. So the complexity here might be Nm, which is far better than M squared for the simple concatenation. We are at the end of this video. I hope you found it useful, and if you enjoyed it, don't forget to give it a like, to hit the subscribe button if you want more content like that, and I see you in the next one. Take care.